Okay, so welcome to lecture number 13. And in the lecture 12, we talked about structure and we gave examples of relational structure and algebraic structure. And then we talked about coordinate geometry, which is how the relational structure can be translated into algebraic structure, right? And we will do this. We'll try to see how does it happen. But before that, let's still be in the world of what a structure is. And I'm not gonna derive whole coordinate geometry out of Euclidean geometry right now. And we will do that later. But for now, let's begin with simple algebraic structure, right? And for that, I have chosen a very simple algebraic structure, right? And that is it's called magma. It's called magma. Now, what is magma? A magma is an algebraic structure, right? An algebraic structure, it means, what do I mean by algebraic structure? An algebraic structure is of the form set and operation. Set and operation put together in a pair in such a way that this operation should satisfy certain axioms. Listen very carefully. An algebraic structure is a pair of a set. That set can be anything. We are not interested in what that set is. Right? This is the beauty of algebraic structure. So we have some set, right? And then we have some operation. And this operation could be binary, it could be unary, it could be zero-ary, it could be tri-ary. I don't know how do we say it. And we will talk about what this binary means. So you take a set and you take an operation and you put together in an closed in a pair in such a way that that operation should satisfy certain property, right? And if it satisfies, then it is algebraic structure. And there are so many algebraic structures, as we have said. But why do we begin with magma? What is magma then? A magma is also an algebraic structure, right? Okay, yeah. So what is magma? So a magma is a type of algebraic structure, right? And it satisfies one property. Only one property it should satisfy, and that is enough to make it magma. So we take a set, I take a binary operation, right? And this binary operation is defined on this set, right? And in such a way that this binary operation has to satisfy one property that is called closure property. It should be closed in the set itself on which we are working, right? And if it does that, then it is a magma, right? So let's do that on here, and so that we can see what's going on, maybe. So we are talking about magma, right? So what is a magma? It is an algebraic structure. And what is algebraic structure? Algebraic structure is a pair, as I said. Take a set, let's say a set A, and then some operation. Operation, for example, we have arithmetic operation, plus, minus, multiplication, division, square root, and so on. So many operations we have. These are the basic operations. So we are going to take an operation, let's say I will call star. Now this star is not multiplication, right? Then what is it? Well, it is not addition, it is not subtraction, it is anything that we can think of. It could be addition, It could be multiplication, it could be difference, it could be division, but it does not have to. It can be anything, any operation we can think of, imagine of. So algebraic structure is a set. A is a set, any kind of set, and this is some operation, right? Now what is a star? A star is a binary operation. Binary operation means what? What does it do? It has this function, it has this property. It is defined on this set A cross A to A. What does it mean? It means this binary operation is gonna take one element from here. Let's call it the element is A. One element from here, that is B, and in between this operation will function. So A star B, and it produces and it goes in A. It means A is in the set A. That is why we can take it from the set A, this element. B already is in the A, so we are taking this B from the set A. Now we are doing some kind of operation in between A and B, and we ask what is the result of A star B, and that result is, let's say it is C. Let's say it is C. So now we ask, does C goes in A? Is C inside A? If yes, then yes. This binary operation satisfies the property called closure. So what is a closure? So closure is closure property. So what is magma? Not closure. What is magma? So magma is an algebraic structure A star such that this star take a set A and another set A, it does the cross product and it produces an element in set A, right? So this is a magma, right? This is the most simplest kind of algebraic structure, right? Most simplest kind of algebraic structure. For example, we can take an example. Let's say our set is A equal to 1, 2, 3 and so on. It is a set of natural number, right? Now let's define an operation. Let's say this star. Right now this star is abstract. We don't know what it is. It could be plus, it could be addition, it could be subtraction, anything. For now, let's say this star, we define it as plus. Let's say, right? Now we form this pair A comma plus. This our set A, and this operation here it is plus. So here it is plus. Now we check if it is closure or not. So what is closure? So what is plus gonna do? Plus is going to take this set A, do the cross product itself, and it produces an element in A, right? Yes. So let's choose one element from here and one element from here. So this is the same set. So let's say here we are going from this set we are going to choose any two elements. So let's say our first element A is 5. Let's say second element is 3. We cannot choose -1 because -1 is not in the set. So we chose 5 and 3 and they both are in this set. So from this set we chose 5 and from this set we chose 3. Both are the same set, so it does not matter. So 5 and 3. Now what are you going to do? We are going to take cross product. If we take cross product, you get 5 comma 3. Now what does 5 comma 3 means? 5 comma 3 means take this plus sign and put in between this number 5 and 3. So 5 comma 3 here means take this number 5 and 3 and put plus in between them. So we put plus. So what we get? The answer is 8. Now this is not enough because it says take an element from here, take an element from here, form an order pair, then do the addition of these two and see if this belongs to this, because here is the arrow. So any number it produces, it must lie in the A itself. So we check, is it, does it belongs to A? So we see here A. Does it have A? 8? Yes. It is a set of natural numbers. Somewhere here it is 8. It means it satisfies this property is called closure. Closure means closed. Any number this pair produces should lie in the set A. And any number that we are gonna take, they both should be from the A. Let's do another example. Suppose here A equal to 10, B equal to 1. So what this plus is gonna do, take this order pair 10 comma 1, right? This 10 is coming for this set, this one is for this set, and both are same set. So the operation is defined on the same set. So we do the operation now in between 10 and 1. So we get what? 10 plus 1, which is 11. Now we check, does 11 belongs to this set A? Well, of course, because it is set of natural number. So 11 is somewhere here. So 11 belongs to A. So closure is satisfied. No matter what number you choose here, you do the addition, the answer will also be in this set. If your both number are from this set, then their addition result is also in this set. And if it is so, then it is called closure. Closure property. Another example of Magma. Take this set, the same set. Now I am going to have a notation n. It is also a set of natural number. Now I am going to define a magma. So we have a set natural number. And now our operation, this star, is dot multiplication. And how this multiplication is defined? It says, what is this multiplication going to do? It is going to take one element from this set and going to cross product with itself, and it's going to produce a number that will be inside this set only. Take an example. So we have to take two elements. N cross n means two elements from here. So let's say A equal to 4, B equal to 3. So what this multiplication is going to do now? So it is going to, so we have two elements, 4 for this one, 3 for this one. So we chose two elements from the same set. Now cross product means make order pair of this. So let's say 4 comma 3. So what is going to do this? What does it mean? It means now in between 4 and 3 we put this symbol. So 4 multiplication 3. What is the answer? So answer is 12. Now is it closed? Well, not really at first. We have to check. Does 12 belongs to this set n? Here. Well, yes, because it is set of natural number. It means it is closure. So it is a magma. It is also a magma. Here it was also magma. It was closure property satisfied. So magma. Right? Here it was magma. So it means a set of natural number with addition. Last time we did example of addition. Here for addition. So it was a magma. So A plus, so n plus, where plus is defined n cross n to n. This is a magma. A natural number with addition forms a magma. Also we saw natural number with multiplication, where multiplication is n cross n to n, it forms a magma. What about this? This natural number with subtraction, where our subtraction is from n cross n to n. Does it form magma? Well, let's check. So we have set of natural number 1, 2, 3 and so on. So what does minus gonna do? Let's take one two elements from this set and make an order pair. So let's say choose two elements. Let's say 3 and 2. So what is this minus gonna do? It is going to put minus sign in between two numbers. So 3 minus 2. The answer is 1. Now does 1 belongs to this set? Well, yes, it does. So is it a magma? Well, not really first. What about this one? Let's say we choose two numbers from here. One from this set, one from this set. Both are same set. So let's say I choose 1, 6. And 1 and 6 are in this set. So what it is going to do? Going to put minus sign here. So 1 minus 6. What is the answer? Answer is minus 5. Now we ask, does minus 5 belongs to this set? Well, no. Because it is a set of natural number. This is integer. It does not belongs to. So it does not satisfy closure property. So this is not a magma. It is not a magma. Right? Addition is a magma, multiplication is a magma. Right? So what does it mean? It means we can do addition in natural number and we can do multiplication in natural number. Right? But it is not a very powerful algebraic structure. The next is a different. Next example could be, let's say, a set of integer. What is the set of integer? We have ... Let's say minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. Right? Now we check, is this a magma? Well, magma with respect to what operation? So let's define an operation. Let's say negative. Is it a magma? Well, to be magma, it must satisfy closure property. Right? So what is negative? How it is defined? It is defined as take Z, cross Z, and the next number should be within Z. Right? Now we take two numbers from this set. So let's take two numbers. Let's say minus 3 and minus 4. So what this minus is going to do, it's going to put minus sign in between this. So minus 3 minus, and this is minus 4. So answer is minus 3 plus 4, which is 1. Does 1 belongs to Z? Yes, of course, here it is. So it is a magma. It is a magma. You can check more. You don't have... See, I only checked for one element, one case. You have to check many. Right? I know that it is already a magma. That's why I am not checking other ones. I know it is a magma. But if you don't know, then what are you going to do? You have to check so many combinations. Right? It comes with practices. Now, is it a magma under multiplication? Well, Z dot. So what is it going to do? This dot is going to take two elements from the same set and produces another element in the same set. So let's say we choose some number minus 3 and let's say another number is 2. These both are coming from the set because all elements should come from this set. So now what is this order pair means? It means in between these two numbers, multiplication will be there. So minus 3 dot 2, the answer is minus 6. Does minus 6 belongs to our set? Yes, here will be minus 6. This number is up to infinity in the both side. Right? So it means Z in dot is magma, satisfy closure property. Z minus is magma. And you can also check Z with respect to plus is also magma. Right? But Z with respect to division is not magma. And we will do this in next video. For now, thank you.